Hi guys, today we will be learning how to model, solve, and graph inequalities. So far we've learned how to graph inequalities, so let's start with a quick review. When we see the less than or greater than sign, this means that we will graph with an open point and the number cannot be included as a possible solution to the inequality. So we have two examples down below. In the first one, we see x is greater than 2. So if we were going to graph this point, I would want to put an open dot on 2, positive 2. Because I don't see the equal to sign underneath my greater than sign, I cannot close in this point. It remains open and the 2 cannot be included as my solution. How do we know which direction to graph this? You will always read the inequality out loud, starting with the variable. So no matter where the variable is, we'll start there. So x is on the left, so we'll read from left to right. This inequality reads x is greater than 2. So then we'll pick a number for the variable that would make that statement true. 3 is greater than 2. So I will want to graph in the direction of that number that I chose. So 3 would be to the right of 2, so I want to graph to the right. So the solution is all the numbers that are greater than 2. In the example down below, if we're using this same strategy, we would read from the right to the left this time because our variable starts on the right. So we would read this inequality as y is less than 8. Because the equal sign is not included and it's just the less than symbol, I'm going to put an open point at 8, and I know that 8 cannot be included as a possible solution. So then I'm going to pick a number that would make that statement true. 7 is less than 8. So I'm going to graph in the direction of 7, which is to the left of 8. Notice how I'm making an arrow at the end, because it doesn't end when the number line here ends. It can go on forever and ever. It's any number that is less than 8. Next, we have a few examples that include the equal to sign. When we see the equal to sign in an inequality, that means we can graph with a closed point, and that number can be included as a possible solution to the inequality. So down below, we would read the inequality out loud starting with the variable. Our variable x is on the left. So I would read this inequality as x is greater than or equal to, because we see that bar down below, 3. I am going to start by graphing a closed point at 3. And then I want to pick a number for the variable that would make this statement true. 4 is greater than or equal to 3. So I would want to graph in the direction of 4 to the right. The second inequality, I see my variable is on the right, so I'm going to read out loud starting from right to left. So I see y is less than or equal to 5. I'm going to start by plotting my point at positive 5 and closing it in because I see that equal sign down below. Next, I want to pick a number for the variable that would make that statement true. 4 is less than or equal to 5. So I would want to graph in the direction of 4, which is to the left. Now we will learn how to model and solve inequalities. When modeling inequalities, we can model just like we model equations, with using an inequality sign instead of the equal sign. We have an example down below, a word problem. It says, on a day in January in Watertown, New York, the temperature was 5 degrees Fahrenheit at dawn. By noon, it was at least 8 degrees Fahrenheit. By how many degrees did the temperature increase? Down below, this word problem has been modeled for us. The long rectangle will represent our x, and then we see 5 next to it. That represents the temperature it was at dawn. So on the left, we could write x plus 5. Then we see a greater than or equal to sign, and on the other side of our model, we see 8 squares, 8 positive squares. That represents the temperature that it was by noon. One important thing to keep in mind is that unlike equations that only have one correct solution, inequalities have multiple solutions that are possible. Going back to our word problem from before, since we know in order to solve an inequality, we solve it just like an equation, in our model above, we would subtract or take away 5 positives from each side, giving the answer of x is greater than or equal to 3. Next, we would want to come up with some other solutions. Since inequalities have more than one solution, we will come up with a few examples. So, other solutions we know that 3 can be a solution because we see the equal to sign, so we know that's a closed point on the graph, and we know 3 is a solution. If x needs to be greater than 3, we can pick any numbers that are greater than 3 as well. So 4 could be a solution, 6 could be a solution, 8 could be a solution, and even 10 could be a solution. You can come up with more solutions as well. These are just a few examples. All of these numbers are greater than or equal to 3. Last, we're going to check our work. Just like we check to see if equations are correct, we are going to check to see if our inequality makes sense with our solution. So we are going to substitute or plug in one of our possible solutions back into the original inequality to check to see if it is a correct answer. So our original equation was 5 plus x, so we're going to choose 3 for x because I know that 3 can be included, and that is greater than or equal to 8. We're plugging our answer of 3 back in, and we're going to check to see if it's correct. So 5 plus 3 is 8, and 8 is greater than or equal to 8, So we know we solved this inequality correctly. Now let's solve some guided practice problems together. For question 1, I noticed that there is a key for my model to help me write my inequality. So the person represents X and the hot dog represents 1. So I see 2X on the left. I'm going to keep my inequality sign, less than, and the 6 hot dogs represent 6 on the right. Now I'm going to solve my inequality just like I would an equation. In order to get X by itself, I see its multiplication, so the opposite of multiplying by 2 is to divide by 2 on both sides. The 2's will cancel each other out, leaving X by itself on the left. We're going to keep the inequality sign the same, and 6 divided by 2 is 3. So our answer to our inequality is X is less than 3. Next, we'll think about what those possible solutions could be for our inequality. So all of the possible solutions are going to be all of the numbers less than 3. So I can choose any number that is less than 3 to check and make sure that my inequality is correct. So I'm going to write my original inequality. 2 times, I'm going to pick 2 for X, 2 is less than 3, is less than 6. 2 times 2 is 4. And 4 is less than 6, so I know I solved this inequality correctly. In our second question, I see 3x on the left. I'm going to keep the inequality sign the same. It's greater than. And I see positive 9 on the right. Again, I see multiplication, 3 times x. So in order to get my x by itself, I would want to divide both sides by 3. When I do, x is now by itself on the left. The 3's cancel each other out. I'll keep my inequality sign the same, and 9 divided by 3 is 3. So all of my possible solutions for this inequality are all of the numbers greater than 3. So next I would want to check and plug in a possible solution into my original inequality to check to see if it is correct. So I see 3 times, I'm going to pick 4 for x because that's greater than 3. And then the inequality reads as greater than 9. So 3 times 4 is 12, and 12 is greater than 9. So I know I solved this inequality correctly. This time we are given inequalities and we need to draw a model for each of our 2 problems. So for the first inequality, I see 4x is greater than 16. I'm going to start by drawing 4 x's on the left. I'm going to write my inequality sign in between, and on the right I'm going to put 16 dots. 12, 13, 14, 15, and 16. So we know that we would need to divide by 4 on each side of our inequality in order to get x by itself. So to show that in our model, we would want to evenly distribute our 16 dots for each x. And when we do, we find that there are 4 dots per x. So we can highlight those. When we divide 4 divided by 4 on the left-hand side of our inequality, we get just x by itself. We keep our inequality sign in the middle, and then 16 divided by 4 is 4, represented by our model. So our solution is x is greater than 4. So I would want to pick a number that makes that statement true to plug into my original inequality to check my work. So my original inequality reads 4 times a number. I know x needs to be greater than 4, so I'll choose 5. 5 is greater than 4. And the inequality reads is greater than 16. 4 times 5 is 20. 20 is greater than 16, so we know we solved this correctly. For the next problem, I see x minus 4 is less than negative 3. So in my box on the left, I am going to draw an x and then 4 negative counters. Remember, when we see subtraction, we can always do keep, add, opposite, keep the x, change subtraction to addition, and the opposite of positive 4 is negative 4. So that's how we get the negative 4 counters. On the other side, I see negative 3 counters. 1, 2, 3. And we want to keep our inequality sign in between, the less than symbol. So if we go up to our inequality, we know we would need to add a positive 4 to both sides to get our variable x by itself. So I could add positive 4 to the left side and positive 4 to the right side. And then I can cancel out my 0 pairs. Okay, I have a negative, 1 negative, 1 positive. Here's another 0 pair, another 0 pair. So these all cancel out, and we have x by itself. On the left, I can cancel out 3 of the positives and 3 of the negatives, and we're left with 1 positive. So x is less than 1. To check, I'd want to plug in a number that would make that statement true. So x needs to be less than 1. I'm going to choose negative 1. And then we had minus, or we turned that into plus a negative 4, is less than negative 3. When I add negative 1 and negative 4 together, I get negative 5. Negative 5 is less than negative 3, so I know I solved this inequality correctly. Now we're going to solve a few more guided practice problems together. For each problem, we will solve the inequality, give 3 possible solutions, and check our work by substituting one solution into the original inequality. Our first problem reads 2x is less than or equal to negative 12. I see multiplication because I have a number right next to a letter, so I would want to divide by 2, that same number, on each side of my inequality. When I do, my 2's on the left cancel each other out, and I'm left with just x. I'm going to keep my inequality sign, and 12 divided by 2 is 6, and it would be a negative 6 because I'm dividing two numbers with opposite signs. So now we would want to come up with 3 possible solutions to this answer for our inequality. So x needs to be less than or equal to negative 6. Well, it could be equal to, so we'll use negative 6. Okay. Negative 7 is less than or equal to negative 6, and negative 8 is also less than or equal to negative 6. You could also choose different solutions. These are just the ones that we came up with. So now I'm going to choose one of these possible solutions and plug it into my original inequality. So we had 2 times, I'm going to choose negative 7 is less than or equal to negative 12. 2 times negative 7 is negative 14. That is less than or equal to negative 12. So we know we solved this correctly. For question 2, I see x minus 17 is greater than or equal to 49. I'm going to use keep, add, opposite to turn this into an addition problem. So I'm going to keep the x, change subtraction to addition, and the opposite of positive 17 is negative 17. To get x by itself, I would want to add a positive 17 to both sides because my number is negative by my x. The 17s on the left will cancel each other out, and we're left with just x. I'm going to keep my inequality sign, greater than or equal to, and when we add 49 and 17 together, we get 66. So our solution is x is greater than or equal to 66. So now we want to come up with some possible solutions that would make that true. 66 can be included because we see the equal sign. And then I'm going to choose 70 is greater than 66, and 75 is also greater than 66. When you're choosing possible solutions to plug back into your original inequality, choose numbers that will make it easy for you to do so. So I am going to choose 70 to plug in. So 70 plus negative 17 is greater than or equal to 49. When we add positive 70 and negative 17, we get positive 53. We need to subtract the two because they have different signs, and we kept our answer positive because we had more positives. I'm going to keep my inequality sign the same, greater than or equal to, and 49 on the right. 53 is greater than 49, so we know we solved this correctly. Next we see 96 is less than 8 times x. To get x by itself, I will divide both sides of my inequality by 8. The 8's on the right cancel out, and we are left with just x. I'm going to keep my inequality sign, and 96 divided by 8 is 12. If we weren't sure, we could go off to the side and we could do our long division, and we would find that it does equal 12. So remember, when you are reading your inequalities, you always want to start with the variable and read from there. So the variable is on the right, so I would want to read from right to left. So I would read this as x is greater than 12. So now I would want some possible solutions that would make that statement true. 15 is greater than 12, 20 is greater than 12, and 22 is greater than 12. Those are all possible solutions. They are not all of the solutions. So now I'm going to check my work and plug one of those solutions into my original inequality. So 96 is less than 8 times, and I'm going to choose 20 because that would be easy to work with. All right, 96 is less than 8 times 2 is 16, and we add on the 0, so 8 times 20 is 160. 96 is less than 160, so I know I solved this correctly. For question number 4, I would want to use keep add opposite. So I'll keep the x, change subtraction to addition, and the opposite of positive 13 is negative 13. So to get x by itself, I would want to add a positive 13 on both sides. So the two 13s on the right will cancel each other out, and we're left with x. And 5 plus 13 is 18. And remember, since our variable is on the right, when we're thinking about possible solutions, we want to read out loud starting with the variable. So we'll read from right to left. So x is less than 18. Okay, well, what's less than 18? I'm going to pick some easy numbers to work with to plug into my solution. So 2 is less than 18, 5 is less than 18, and 15 is also less than 18. So those are all possible solutions. So I'm going to choose 15 to plug into my original inequality. 5 is greater than 15 plus negative 13. When we solve, we get 5 is greater than 2, and that is a true statement, so we solved our inequality correctly. For question 5, in order to get x by itself, I would subtract 29 from both sides. I'm left with x by itself on the right. I'm going to keep my inequality sign, and when I add negative 12 plus negative 29, I get negative 41. So if we were going to read this out loud, we would say x is greater than or equal to negative 41. So we want to find some possible solutions that would make that true and solutions that would make it easy for us to plug into our original inequality. So negative 30 is greater than or equal to negative 41. 2 is greater than negative 41, and positive 5 is also greater than negative 41. So I'm going to plug in positive 5 into my original inequality to check. Negative 12 is less than or equal to 29 plus 5 for x. So when we solve and we add 29 plus 5, we get 34. So negative 12 is less than or equal to negative 34. That is true. So we solved this inequality correctly. For question 6, I would need to subtract 21 from both sides to get x by itself. On the left, I'll keep my inequality sign. It's less than. And we have a positive 14 and a negative 21. When we add those together, we would get negative 7. So x is less than negative 7. What numbers are less than negative 7? We could choose negative 8, negative 10, and negative 11. Those are all going to be less than negative 7. So I'm going to choose negative 10 to plug into my original inequality to double check. So negative 10 instead of x plus 21 is less than 14. When I add negative 10 and 21 together, I would get a positive 11. I have to subtract the two numbers because one is positive and one is negative. I have more positives than negatives, so my answer was positive. I'm going to keep the inequality sign and the 14 on the right. 11 is less than 14, so we know we solved this inequality correctly. For question 7, I see my 10 is negative and it's being added to x, so the opposite would be to add a positive 10 on both sides. To get x by itself on the right, I'll keep my inequality sign, and negative 41 plus positive 10 is negative 31. So to read this out loud, we would say that x is less than or equal to negative 31. So to come up with some possible solutions, I know negative 31 can be included. So I'll plug that in. Negative 32 is less than negative 31, and negative 33 is less than negative 31. So to check my work, I'm going to plug in negative 32 into my original inequality. So we have negative 41 is greater than or equal to negative 10 plus negative 32 for x. Okay, so we have negative 41 is greater than or equal to, and when I add negative 10 and negative 32 together, I get negative 42. So this reads negative 41 is greater than or equal to negative 42. That is a true statement, so we solved that correctly. Over on the right, for question number 8, we see that we don't have whole numbers anymore, we have decimals. That's okay, we're still going to solve the exact same way. So we see that there is multiplication on the right, so we are going to divide instead by 3/10 on both sides of our inequality. The two 3/10 on the right cancel each other out, and we're left with just x. We'll keep our inequality sign in the middle, and when we divide out 4 2/10 divided by 3/10, we would get a positive 14. So to read this, we would want to read from right to left because our variable starts on the right. So we would read this as x is less than or equal to 14. So we know 14 can be included, so we'll include that as a possible solution. 10 is less than 14, and 11 is also less than 14, so we'll choose those as well. I'm going to plug in 10, because that's an easy number to work with when we're multiplying, into my original inequality to double check my work. So we have 4 and 2/10 is greater than or equal to 3/10 times 10. When we multiply by powers of 10, we just have to move our decimal point one space over to the right, or you could multiply it out on the right, and when you do, you would find that it equals 3, positive 3. So 4 and 2/10 is greater than or equal to 3. That is a true statement, so we know we solved this correctly. For question 9, we see a fraction next to our variable on the left. So remember, when we see that, we need to multiply by the reciprocal on both sides. So instead of 1 over 2, we're going to multiply by 2 over 1 on both sides of our inequality. Okay. The numbers on the left will cancel each other out, and we're left with just p on the left. We're going to keep our inequality sign, and since we're multiplying by 2 over 1, we're really multiplying by a whole number. So we could just multiply -4 times 2, and when we do, we get -8. So p is greater than or equal to -8. Okay, so we can include -8, and then 2 is greater than -8, and 3 is greater than -8, so those could also be some possible solutions. So to check our work, we're going to plug in 2 into our original inequality. So we have 1/2 times 2 is greater than or equal to -4. To turn my whole number into a fraction, I can just put that over 1. When we multiply across, 1 times 2 is 2. 2 times 1 is 2. So we get 2 over 2, which is equal to 1. So 1 is greater than or equal to -4. That is a true statement, so we solved this correctly. For question 10, we see division. X divided by 5 is less than 6. So I would need to do the opposite, which is multiply, and I would want to multiply 5 on both sides of my inequality to get x by itself on the left. I'll keep that inequality sign, and 6 times 5 is 30. So x is less than 30. What are some numbers less than 30 that are easy to work with? 10 is less than 30, 15 is less than 30, and 20 is less than 30. I'm going to plug in 10 into my original inequality to double check. So I'm going to plug in 10 for x divided by 5 is less than 6. 10 divided by 5 is 2, and 2 is less than 6, so we know we solved this correctly. Again, for question number 11, we see division, x divided by 7. So to get x by itself, I would want to multiply by 7 on both sides of my inequality. I'm left with just x on the right. We'll keep our inequality sign, and when we multiply 7 times -4, we get -28. So when we read this out loud, we would say that x is greater than or equal to -28. So we know that negative 28 can be included as a possible solution because we see the equal to sign. 7 is greater than negative 28, and 14 is also greater than negative 28. I'm looking at my division problem that I'm going to need to do when I check my answer, and I'm picking some numbers that I could plug in that would make it really easy for me to check that. So I am going to choose 14 to plug into my original inequality. So I have negative 4 is less than or equal to 14 divided by 7. 14 divided by 7 is 2. So we'll bring down everything else. So negative 4 is less than or equal to positive 2. That is a true statement, so we solved that correctly. Our last guided practice problem that we will do together, I noticed that there is a fraction next to my variable again on the right, so I would need to multiply by the reciprocal of that fraction on both sides of my inequality. So I'm going to multiply by 3 over 2 on both sides of my inequality. I'm going to put that whole number 8 over 1 so that I can multiply across. The two fractions on the right cancel each other out and we're left with just x. We'll bring down that inequality sign and then I'm going to multiply across. So 3 times 8 is 24. 2 times 1 is 2. And this can be simplified to 12. So to read this out loud, we would say that x is less than 12. So what are some numbers that are less than 12? 10 is less than 12, 8 is less than 12, and 6 is less than 12. Those are all possible solutions. So next I'm going to double check and I'm going to choose one of those to plug into my original inequality. I'm going to choose 6. So we have 8 is greater than 2/3 times 6. And I'm going to need to put that whole number over 1 to turn that into a fraction. So when we multiply across, 2 times 6 is 12. 3 times 1 is 3. We get 8 is greater than 12 over 3. And that can be simplified to 4 wholes. 12 divided by 3 is 4. So 8 is greater than 4. That is a true statement, and we know we solved this correctly. Next, you will work on your independent practice. You will be solving and graphing inequalities. Remember to reference these notes if you need them and ask for help if you have questions.